Okay,
Great.
perfect.
That's perfect.
So, good afternoon, or good morning, or good evening to everybody, depends on where you are. My name is Alessandro Pampado, and I'm a PhD student at the Desktop Department of the University of Pisa. And today, I'm going to present you Exploring Uncertainties in Future Power Systems, Methodology and Analysis for Italy 2040. In particular, I'm going to first introduce you the topic and the motivation why we decided to have such a topic, and then I'm going to focus on the methodology. And last, I'm going to show you the most relevant results in order to understand the impact of our work. So if it works, okay. I can start saying that we as University of Pisa are part of the Resilient project, whose goal is to develop an open source multi-energy system, these pipes are Europe, including uncertainties. That is because we know very well how the energy systems are built today, but we don't know how they will be in the future. The only thing that we're sure about is that we're gonna handle a lot of uncertainties. So these have to be taken into account our system and modeling approaches. Because of that, we decided to model Italy. First of all, because Italy is our native country and we wanted to have a deep look into it, but also because it is a country affected by uncertainty. And we could see it, for example, during the Russia-Ukraine war, where we had high volatility associated to prices of electricity and natural gas. However, if we look at the literature, we see that the studies usually consider just one base scenario, so they do not explore the evolution of the energy system under different pathways and under different external and uncertain conditions. And furthermore, studies usually have a low spatial and temporal resolution, which means just one node mainly, and the use of representative days. Mm, or even worse, if they consider just Italy as isolated by other countries, which is a very uh, huge assumption because Italy is a highly gas importing country. So everything is related to uncertainty to this. So what we are proposing now here is, first of all, a definition for a procedure to get scenarios in a robust way, and then the development of a PIPESA-based Italian model, which is first validated for 2019 historical data, and then validated for 2040 with respect to the date scenario that is developed by Terna and SNAM in the DDS document. And last, we're going to explore the evolution of the power sector under different uncertainty conditions and different scenarios. Talking about scenarios, we got here on the left the procedure, the framework to get them. We start from analyzing institutional regulatory context in Italy, so PNIEC and DDS documents, and we couple this with a literature review on uncertainty because we have to understand which are the most important parameters to take into account to generate the scenarios. After that, we select the modeling tool, that is PIPESA Europe, clearly, otherwise I wouldn't be here. And last, we can define the scenarios in an iterative process because we have to be sure that what we are producing has an impact and it's not irrelevant. So the scenarios that we consider are indicated on the right. Of course, there is also the base scenario for 2040, that is date, that covers the assumptions from the DDS document, even if we adopt, for example, PIPESA technology data instead of their techno-economical assumptions. By the way, the others are the LED with a lower value of electricity demand compared to the date scenario, another scenario with a lower values of prices for fossil fuels. Then we have NCL and bio, that are scenarios that involve the possible installation and expansion of nuclear or biomass power plants. And just a quick note, nuclear is not present in the energy mix for Italy right now, but it is an hot topic at the moment. There is public discussion about that. And the last three scenarios are related to net zero emissions. So no CO2 is just net zero emissions, while NCL CO2 and bio-CO2 are net zero combined to possible installation and expansion of nuclear or biomass power plants, of course, to 2040. Everything is referred to 2040 except for the validation at the beginning. Just a couple of words about the model in the pipes of Europe. You can see on the right the optimal size of generators and stores for 2019 on top and 2040 below. As you can see, also, we are considering not just Italy, but the neighboring countries, because otherwise it would be a very big assumption. So on the spatial resolution, we got 60 nodes, 30 of them in Italy, while on the temporal side, we have 1 year as time horizon and 1 hour resolution. I'm underlining that we are considering an electricity-only model, which is, of course, an assumption and simplification, since PIPESA Europe involves the sector couple, but we wanted to do so in order to have a fair comparison with the DDS that is electricity focused and not sector couple focused. So the models that we consider are, first of all, a dispatch model for 2019 in order to validate pipes against historical data, and then a capacity expansion for 2040 in order to compare our results to the date scenario. And last, several capacity expansion models in order to understand and how the system can be in the future under the different uncertain conditions. Moving now to the results, we can start from the validation for 2019. Here I'm indicating on the left the installed capacity, on the right electricity generation, and below the cross-border flows for such a year. In particular, we have PIPESA data in Ciano and Terna historical data in blue for the comparison. As you can see from the left, so the installed capacity, PIPESA is able to capture the trends of the correct sizes, so we're happy about that. There is just a small underestimation on the thermoelectric side, which is, by the way, compensated in the electricity generation, as you can see on the right. Furthermore, cross-border flows are well approximated. There are some mistakes, but I'm gonna explain you why in the following slide, because it is more evident for 2040 scenario. In fact, if we consider the same graphs, but just for our capacity expansion model compared to the date scenario from Terna and SNAM, we see, first of all, from the installed capacity that PIPESA prefers onshore wind turbines instead of PV system, which is mainly due to techno-economical assumptions that are different and potentials. So it's okay also because on the right, you can see that the sum between PV and wind is constant for the two models, more or less, which means that the percentage on the total amount of energy is more or less the same. So we are happy about that. We are also happy about the approximation of cross-border flows because, of course, there are some mistakes, but these are mainly due to the simplification in the representation of other countries that have few nodes. For example, Greece has just a couple of nodes, or Austria the same. And even more important is the fact that we are not considering all Europe, which means that, for example, Greece is isolated, as well as Austria. I mean, it's not isolated totally, but also France does not have a link to Germany or Spain, which means that we have a change in the ways that we are exchanging energies. So it's not 100% well represented, but the trends are correct, so we're happy about that. The last type of results is related to the scenario analysis. Here I'm representing on the left the optimal size for our generators, and then on the right the energy generation for the year. Of course, for each scenario, so we got a lot of colors. The red is the date, so the one that I just indicated in the previous slide, while all the others are the ones that I explained before. I know this might be a bit confusing, so I just want to point out a few things. First of all, the role of biomass that could be important if we allow the expansion of biomass power plants in Italy, especially if we have net zero emissions, and you can see it with the purple line. We have to be careful, by the way, because biomass is a very generic term, which means that, yeah, we have an electricity-only model, so we have to consider at this resolution the term biomass, but there is a lot more to discuss about which type of biomass and how should be the potential, also because from the DDS or PNIEC, they are not considering a huge expansion in it. By the way, it is worth noting that it could be a good technology for the future of Italy, and we should focus on that for future studies. On the contrary, nuclear is never included, even if we allow the installation and expansion, and this is mainly due to the techno-economic assumption. So the capex is too high, so it's not cost competitive under our assumptions. Of course, the consideration of sector couple could change a little bit, so we're going to deepen it in the future, but at the moment, it doesn't seem cost competitive. The last aspect is related to wind onshore photovoltaic. And as you can see, the lowest size of our plants, and therefore the lowest generation, is obtained with the net zero emissions scenarios, which may seem a bit strange, isn't it? Actually, it is not, and the answer is found. We can find it in this graph here on the left, which represents the hydrogen size and generation for the different scenarios on a logarithmic scale. As you can see, for the last three scenarios that are the net zero ones, we have a huge increase in hydrogen, and I would say unrealistic increase in the size, because we reach values up to 2,600 gigawatt hour, which is kind of 10 times what the DDS and NIC were assuming in the most optimistic scenario. So a very high overestimation of what reality could be. And on the right, you can also see that they are also associated to the highest electricity price, which means that mainly net zero emissions in Italy for 2040 at the moment is a bit unrealistic. Just to conclude, I want to summarize what I've already told you. So our model shows good agreement with 2019 historical data, and also for 2040, if we compare it to that scenario. We have some differences there, but they're mainly due to techno-economical assumptions, so we're okay with that. Biomass could play a crucial role in the future, but we have to be very careful about that, so we're going to deepen it in future studies, as well as we're going to deepen the role of nuclear, because it's not cost competitive at the moment, so the model never includes it. Last is the fact that net zero scenarios are a bit unrealistic under our assumptions, because they are a very high deployment of hydrogen and a very high cost as well. So what we plan to do now is, first of all, as I mentioned, probably at least 3 times to move to sector couple in order to have a complete view of our system and the role of Italy in the energy transition, also including all the other countries, in order to have an European model and avoid the problem of simplification of the other countries. In the meantime, we're also working in stochastic optimization in order to include uncertainty in a coherent way, because here I'm including it, but it's just a deterministic approach, but stochastic approach could give us a more robust solution and a more way to study a bit better the system. So thank you very much for your time, and now I'm here for your questions or curiosities or whatever. Thank you.
Thank you, Alessandro. And yeah, we have a lot of questions for you, actually. So we'll start with this one. Can you please explain more about the model validation? How much was the error percentage with respect to the actual system?
Okay. I mean, if you want, you can also text me later, because there is a lot to say about that, because we validated basically 3 aspects. So the sizes, the electricity generation, and the cross-border flows. I don't have the error indicated right now, but for the sizes, the error are very, very low. For example, for the renewables are close to 0%. We just have something like 3% for thermoelectric size. On the generation, we have errors up to 5%, and similar things are related to cross-border flows. The only different case is, for example, to Montenegro, because we have a very small value of cross-border flow, so the error, a relative error is high, but the absolute error is low. So it is still acceptable if this is for 2019. If you're interested a bit more, you can just text me and I'm going to show you the results much more in detail. Otherwise, we don't have time. I would spend 1 hour just for that.
Okay, thank you, Alessandro. Then the other question is, which are the assumptions for nuclear in terms of costs, technologies, and introduction pathways?
Yeah, the assumptions are mainly related to what you can find at the Biosol technology data for year 2040. The investment cost, I just remember it, is about 8,000 per kilowatt, more or less, which is something I think correct at the moment for the cost that we have right now. We are not considering a development of the technology with small nuclear reactors or whatever, but the technologies that we have right now. The introduction pathways are not well included in this model because we have an overnight scenario. So we're just optimizing the whole here, assuming we are in 2040. So we didn't adopt a myopic optimization in which you could see after every 5 years, for example. So there is not a correct introduction pathways. Then if you want to explain it a bit more, I'm glad to reply to it.
Okay, thank you for your answer. Then we definitely have time for some other questions. So if a technology is preferred in terms of capacity by the model but not feasible in reality, how can you restrict it?
Well, the simplest way is just to cut the technology from the list of the expandable ones if you think it's very, very imprecise what you're finding. Otherwise, you can just limit it. For example, I mean, the point is, unless you have a very detailed model and you add unique commitment, reserves, modularity, a lot of things, the capital and marginal cost will be the best thing the model is looking for. So sometimes it doesn't follow the real conditions that you have. I had the same problem for geothermal power plants that have, of course, a very low marginal cost, but you cannot expand them a lot because if you have nothing to extract, you have nothing to expand. So a current way is just at a certain point, if you see that it is unreliable, you can just limit the expansion, limiting, the PNOM. So you got PNOM max, following some literature references that are reliable.
Okay. Another question is, was biomass being penalized with its CO2 emissions in your emission reducing scenarios?
Not at all. Also because biomass here has not CO2 emissions included because it has net zero emissions. That is the assumption. So during the lifetime of biomass, it takes CO2, and when you burn it, it's just a net zero value. So it's not penalized. In fact, as you could see, but if you text me, I'm gonna show you a bit more in detail. The net zero emissions with biomass expansion forced the biomass to be very, very exploited. So it was an interesting part.
You maybe put together a few questions here. So I think this is very simple. Is this PIPESA Earth or PIPESA Europe?
This is PIPESA Europe, and the Italian model is not online in the sense that we have a subfolder of PIPESA Europe, but we are planning to do it. But I can share afterwards my GitHub page in which I have the link of and the repo where I work for this paper. But there is not a PIPESA IT ready at the moment.
Okay,
yeah, if this study is available.
Sorry, yeah, maybe I just read the questions just to let everybody hear them. But yeah, please, if the study is available.
Yeah, sorry. The study is available. I can share also the link to the study. I presented it at the Greta conference, IEEE, July. So yeah, we are gonna develop it a bit more. So if you're interested in that, just write me, and we're gonna consider it.
And then will Greece be able to provide that amount of electricity on slide 5? Should Italy need to import more power based on your PIPESA model results?
This is one of the. Thank you for your question because it's very interesting and one of the problems that we faced actually. The fact that Greece is expanding a lot in terms of renewables because the model finds it very interesting in terms of cost. So we got a very mismatch in what we expected and what we obtained because Greece is isolated and the model tends to use it to provide a lot of renewables during summer, and this changes a lot the cross-border flows, of course. If it will be able to do it, yes, because we at a certain point it was so unrealistic that we limited the expansion on the lines between Italy and Greece in order to reach the level assumed from the literature for 2040, and in order to avoid a very higher overestimation. So we limited the problem, but I mean, it's an imprecise result from pipes, I would say.
Uh, I think yeah, we still have time for maybe this last question. Oh, maybe I'll go with the one about Greece since we are touching the topics. Would Greece like exporting electricity to Italy?
I mean, do you mean in reality or in the model? Because in the model, Greece loves exporting electricity to Italy because they have wind and PV. So during summer, we saw that there is a peak of energy with zero marginal cost that instead of being, cut, so curtailed, you just send it to Italy, and we're very happy about that. In reality, I don't know if they will be happy about that.
Thank you. I didn't want to make your life difficult by asking that. So maybe I'll ask Zio to post the remaining two questions in the chat so that Alessandro can answer them. And thank you again for your insightful presentation and for your
Thank you.
answers, many answers actually.